Okay, so our work today is going to focus on statistical inference for a difference in two proportions. So our setup for this problem is for the response project, the response bias project, a group of AP Stat students, they investigate whether the characteristics of the interviewer can affect the response to a survey question. All right. And so they go to the Stonebrower Mall in Frisco, Texas, and they ask a random sample of 60 shoppers the question, do you like tattoos? All right. And for 30 of the shoppers, the interviewers were wearing clothing that covered their tattoos. And for the remaining 30 shoppers, the interviewers had their tattoos visible. The choice of showing or not showing their tattoos was determined by a coin flip, right? So it was determined randomly. The group suspected that more people would answer yes when their tattoos were showing. Okay, so let's kind of review the different concepts about what has been discussed in our statistics class up to this point. And that is first, why was it important to randomly assign the treatments, right? Showing or not showing the tattoos in this experiment? Well, the reason would be the following, right? That if we have random assignment, right? If we've got random assignment of the treatments in an experiment, right? We do that to help reduce the effects of confounding variables, also known as lurking variables, right? Such as not showing tattoos to subjects that have tattoos more frequently, right? So if you're not showing that tattoos to the subjects, but the subjects have tattoos, then they may be more likely to say, oh, yes, I do like tattoos. I have some myself, right? Also, random assignment to treatment groups in experiments helps create roughly equal sized treatment groups with similar characteristics between the treatment groups, right? Which also helps to control for those lurking variables, which helps to reduce confounding. Okay? Now, if they're looking for this convincing evidence, they're going to need to do a significance test or a confidence interval. In this case, we're looking for a significance test. So we're asked, what would be the null and the alternative hypotheses the group wants to test? And we have to make sure we define the parameters. All right. So if we consider the null and the alternative hypotheses, we might have something that looks like this. Right? That we have the null hypothesis. We have two different populations. So we might say, hey, that null hypothesis is that there is no difference in the two proportions for the two populations. Right? Whether I was showing or not showing the tattoos, right? Whether those students were showing or not showing the tattoos, wouldn't make a difference to the proportion. And the alternative is that yes, there is a difference. But notice, we have to define our variables. So here we say where proportion 1 is the true proportion of subjects like those selected who would say yes to liking tattoos if the interviewer had tattoos showing. And proportion 2 is the true proportion who would say yes to liking tattoos if they were not showing. All right, so we have to define those variables because that's going to dictate the less than or greater than within our alternative. Then we get to our next question. It says, hey, the results of the experiment are summarized in the two-way table below. State the evidence in favor of the alternative hypothesis. What are the two explanations for this evidence? All right, so this takes us back to things that we discussed at the very beginning of the year. And we say, well, what's our evidence and what are possible reasons for that evidence? So we can look at our situation here. We might say, hey, let's adjust this color, right? That our evidence is that the sample proportion for group 1, 18 out of 30. And the sample proportion for group 2, right, 14 out of 30. Right? Those were the ones that said yes. Well, that difference is 4 out of 30, which is greater than 0. So there's our evidence, right? So once again, we're saying, hey, proportion 1 is saying yes when showing. Proportion 2 is saying yes when not showing. So we find their difference of the two sample proportions, and that difference is positive. So there's our evidence. Now, our explanations are going to always be the same explanations for this evidence, right? One explanation can be that there is actually no difference in the proportion. Who would say yes based on the characteristics of the interviewer? We got a sample difference of greater than or equal to 4 out of 30, right? We got a sample difference of at least 4 out of 30 by chance. Now, what's the other possibility? That there actually is a difference in the proportions. More people would say yes when tattoos were showing, right? That, hey, if you're showing tattoos and you're asking about, do you like tattoos? People may not like confrontation and might say, oh, yes, I like tattoos, simply because you're showing them. Okay. Then we can continue and we say, okay, well, what about if we were to run a simulation like we did in our work earlier in the year? So let's review those ideas, right? The group of students, they conducted a simulation to determine if these data provide convincing evidence that the interviewer showing their tattoos increases the proportion of shoppers who would say they like tattoos. So does the dot plot from the 40 trials in the simulation provide the convincing evidence desired? Okay, so we have a simulation and it asks about the dot plot. It asks specifically about the dot plot, so we have to refer to the dot plot. So in the dot plot, what do we notice? In the dot plot, we notice the following, right? We noticed in the dot plot that at least 8 out of the 40 simulations resulted in a difference in proportions of 0.133. or 4 out of 30 or more, right? That if I count the number of dots, right? If I just count the dots up to 0.15, there's 1, 2, 3, 4, 5, right? 6, 7, and then the one right next to 0.15 is more than 0.133. So there's at least 8 of them, right? Maybe these next ones are close or less than 0.133. Maybe it's hard to tell, but at least 8 out of 40 in our simulation resulted in that difference of 0.133 in the proportion or more. Right? So is that convincing evidence? Well, we can come over and what might we say? We might say the following, right? Since that p-value, the probability, assuming the null hypothesis is true, right? Since that probability, 8 out of 40, which is 0.20, is greater than 0.05, our significance level, there is not convincing evidence of a difference in proportion of those who would say yes to liking tattoos based on whether the interviewer was showing or not showing tattoos. Okay. So this approach that we've been using all year long, we're going to emphasize and work through. Okay. So when we're doing the work, we're going to want to make sure that we're showing everything and that we're being careful in the phrasing that we use. Right? We should still always remember about how to work with simulations. We should remember about how to work with two-way tables. Right? Significance testing, if we're working with two proportions, well, then we need to make sure we're talking about the two proportions. We need to make sure we define the variables. And we need to remember about our experimentation techniques and the importance for what we have to do. Okay? So good luck to you as you work through this